The title of this unit, Linear Relations. We are going to learn about things that have relationships that when you draw their graphs, they end up being straight lines. And this forms a lot of math for this year. A lot of math in grade 10 involves lines. So a little bit of review. You can use a number, this is algebra, you can use a variable, such as x to represent a number. So if someone says, I have something 4 times more than a number, in algebra we would write that as 4 and then x for the number that you don't know. That's your variable, right? Right, because if I said, oh, the number is 7 and you have 4 times more, then your answer would be 28. If I said your number is 2 and you have 4 times more, your answer is 8. So your answer is going to be 4 times whatever number you put in. So we use algebra and x. 5 times a number. Oh, sorry, I did the first one completely wrong. I was reading the second one. 4 more than a number is in times, right? 4 more than a number is you have a number and then you would add 4. I think I added 4 times more in my head. But 4 more than a number is just x plus 4. 5 times a number, that's going to be 5 times x or 5x. How do you write a number divided by 10? How would you write 5 less than a number? How would you triple a number? So try to write them on your own, these next ones. And then I'll put them up in a second and see how you did. How many people on the one, you could write this like this? I like the fraction like that better. Did you get either of those?
Yep.
Can I see?
Like,
Alright.
you feel like imagining that.
Thank you. No, I just need that part.
Alright. Not too much.
Yeah. You can pick it up at the end of class.
Alright. Oh. I want to start.
Thank you.
Just put it on. On this.
And I can get the 5 less than a number. The x minus 5.
Yep.
That's why you got to sit here.
Yeah, maybe.
Maybe not even for work. I don't
Maybe
think so.
if I'll be there, I'll be more for that.
Well, let's see. It doesn't work that way. You got to show that you're productive where you're supposed to be to get privileges if we want to do something else. And triple a number. Triple means 3 times, so that would be 3x. So we got this idea of in algebra we can have an x. Sometimes people, it didn't have to be an x. You could use, oh, I like n for number. You could use 3n because you like n for number. Right? Or maybe, I don't know why, you would like, what letter? Q for number? You could do 3q. So you get to choose whatever variable you like.
Over n plus z.
Yep. Could do 3z. Okay. Numbers to avoid, sometimes, or variables to avoid, sometimes people like to avoid t because t looks like a plus sign. Or they like to avoid the z because the z can look like a 2. O is a terrible one because you're like, was that a 0 or was that an O? So we try to avoid some letters that look too much like numbers. Oh. We got it? A square. Then we have a bigger square. Then we have a next shape, Can you draw what figure 5 will look like? Figure 5. Can you draw the next one? Can you figure out what's happening? Can you draw figure 5? Can you describe to me in words what the heck is happening? Okay. Alright, there, I've drawn figure 4 again. Did you get figure 5 correct? Did you see that that would be figure 5? How many people got figure 5? Okay, awesome. Would someone like to describe the pattern they saw? How do you know what to do the next time? It's going up by 3, so if I draw figure 6, why can't I just draw 3 more like here? That went up by 3. So describe it more. You're right, it's going up by 3 each time.
It's going up by 3 diagonally.
So you're adding those 3 squares on the top right-hand corner of the last square, right? So we have to be able to describe that, because here's my original, right? Here's that same original, and the green is what's new, right? Then, from the last one, here's the last one, and then here's what's new. Now, this was the last one, and here's what's new. And Abel said it perfectly, each time you're adding 3. Now, if we go down, you've drawn figure 5, you've been able to describe it. What we noticed here, and we can make something very important, is a table of values. So we've got figure 1, figure 2, figure 3, figure 4, and we drew figure 5. But I'm not going to put it on here yet. How many squares are there in figure 1? 1. Then in figure 2 there was
3.
No. 1, 2, 3, 4.
Pero investigar, ¿no se supone que los nuevos son los nuevos?
No. How many squares in figure 2? Just the total. Total squares in figure 3? 7. Total squares in figure 4? 10. Without drawing or looking at figure 5, how could we use this to figure it out? Just
13.
Yeah.
13.
And so we notice that each time here we're adding 3, each time here we're adding 1. And if they stay the same on both sides, if you go up the same amount on one side, this side, on the left side I'm going up by 1s, on the right side I'm going up by 3s, if that number is the same, it will always make a linear relation. In other words, what's going to happen later on in this unit is we are going to make a graph. And we're going to put figure number down here. 1, 2, 3, 4, 5. And we're going to put number of squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to go up to 13. This was 10. This is 7. This is 1. This is 4. And if I draw a graph, I've got my scale nice. Look, if I draw these points, 1 was 1, 2 was 4, 3 was 7, 4 was 10, 5 was 13. Look at that. How it makes a perfect straight line when I connect the dots. This is called a linear relation. Okay. What I'm going to get you to do with this linear relation So we got the same one here. Let's rewrite our numbers in here. 1, 2, 3, 4, 5. We know 1 squared, 4 squares, 7 squares, 10 squares, 13 squares. We had figured that out already. And I'm going to teach you a technique that's really cool. Okay? You're going to have to do some mental math. So for somebody it's going to challenge you a bit. Okay? If we didn't draw it, I bet you could tell me how many were in the sixth one. Right? I bet you could say how many are in six. How many? 16. So you have discovered one pattern really easily, that you are going up by threes. But I want you to see another pattern. And the other pattern I want you to see is there's a shortcut to go from here to here. And I want you to see if you can find that shortcut and then figure out 10 for me. If you can't figure out the shortcut, figure out the long way. First person to tell me how much it is going to be when it's 10.
27 or 26?
Oh, you're 20, it's close, you're very close to 27.
26.
No. 28. Okay. And now, I'm gonna get you to do 100. Can you see the shortcut? The shortcut says there is some mathematical way to go from here to here, and the hint is it's going to use a 3 somewhere because that's what we're adding every time.
Hostia, el 100 a 300.
No.
Ah,
Is it like adding, subtracting?
There's could be adding, subtracting, multiplying, dividing,
Is it
and you have to use a 3.
280?
What's your pattern? It's not 280, it's not just times 10 for this one. I like that idea.
298.
298. Oh my goodness.
You took the word down on that.
What did Matthew do? How did he figure that? That seems complicated. But he noticed the pattern. There is a formula to go from this number to this number. And the hint is it will use a 3. Now that formula will include multiplying and adding and subtracting.
Is it like add and subtract the number?
Maybe, but you have to tell me what I need to, like, to go from 10 to 28. How do you go from 10 to 28? You could double it and add 8. Do you see that? I could double 10 and add 8, I would get to 28. What if I double 2 and add 2 again? I get 6. That doesn't work. Whatever formula you come up with has to work for every single one. What do you think the
So
formula?
like doubling and then subtracting one.
So double, subtract 1. What happens if I double 4? I get 8. If I subtract 1, I get 7. No, it doesn't give me 10. And the hint is it's got to use a 3.
I have to do like 3 times 100 minus
3 times 100
and then minus 3.
minus, well, 3 times 100 is 300. What would you need to minus to get to 290? Minus 2. What's 3 times 10?
2. I mean, wait, 3
Oh
times.
yeah.
3 times 10 is 30. Minus 2, does it work?
Mhm.
What about 3? What's 3 times 3?
9.
Minus 2, does it give you 7?
Yeah.
Yeah.
What about this one? 3 times 5? Minus 2, does it give you 13?
Yeah.
You just figured out the formula.
Tested it with one number as well.
Test it with 1. What's 3 times 1?
Oh, never mind.
3 minus 2 works. See?
yeah.
So we just figured out the equation. And this hint, what it's adding by, will always be the multiplying part. So for example, it says, well, let's just go, the figure number I am going to call, I'm going to call F right now and squares S. Later on, we're gonna use X's and Y's a lot, but right now we're gonna use figures and squares. If I do 3 times my figure, how close am I? This one's too much. This one's 6, this is too much. 3 times 3, 9, too much. 3 times 4, 12, too much.
It's 3F next
So-
to-
So is it right? Is the number of squares equal to 3 times F? No. But then you notice they were all how much too much?
2.
All too much, so let's adjust our equation. We're gonna times 3 times the figure number and subtract 2. Use this formula. How many would there be in figure 7? That means F would be 7. The number of squares then would be 3 times 7 minus 2. You're right, 19 squares. That sure is a lot easier than having to draw all of them every time, right? I'm gonna get you to draw the next one, so I know that you see the pattern. But then from there, we look for a pattern. Okay. So, I'm going to, which figure would have 16 squares? Well, we have that in our answers. We can kind of cheat because we already know this. But I'm going to give you one that isn't in our answers. I'm going to say which figure would have 58 squares. Is that listed in our chart here? No. So I'm going to show you a little bit of formula work. We figured out the formula. The relationship was you take the figure number, times it by 3, and then subtract 2. If something had 58 squares, that means I could put a 58 for the number of squares. 3 times something minus 2 has to equal 58.
3 times 20.
3 times 20. Now I'm going to show you a little bit. I'm glad that you can figure that out. Did you just plug in numbers until it got close?
No. You literally, all you have to do
Mhm.
is, just like 3 times 20, right? I'm just using my head 20 times 20% plus 20.
So you did a little bit of guessing and checking. That's perfectly fine. I'm going to show you something that is also in the next 2 units that we're going to do. If we have an equation and you want to solve for f, and I said, I took a number, I multiplied it by 3, then I subtracted 2 and I got 58, and you had to work backwards, do you see that you would be like, well, I could add 2 to this, and if I add 2 mathematically to this side, in an equation we're going to learn what you do to one side, you do to the other. If you have a balance thing, you add 2 to one side of the balance, you'd have to add 2 to the other side of the balance as well. And 2 plus 58, that's easy. Well, change back to blue. That's 60. And now I have 3 times something is 60. What's the opposite of multiplying? Dividing. So now, if I divide this side by 3 and I divide this side by 3, I get the f by itself. And I figure out that it's figure number 20. So what we're going to do is we're going to get into groups and we're going to work on discovering the pattern. I'm going to get you to draw the next one. We're going to work at the whiteboard so you don't have to worry about things. We're going to make the chart. And on your chart, you're going to do the first 4 or 5, then the 10th one, then the 100th one, then write out the formula for me. Okay?
Well, Mr. Jackson Rose?
Hello?
Hi, I'm sorry to bother you. Were you able